Okay, so the lab we're doing is called changing velocity. You need this sheet, and we're going to fill out this graph on the top. What we're going to fill in right now are the times. So you got 3 columns. You got time in gate 1. This is gate 1, and that will be displayed right there. You've got time in gate 2. That's photo gate 2. That will be displayed right there. And you've got the 5th column, that's the time between gates, and that's going to be displayed right there. The time that we're recording that's going through is the flag on this card. It's just an index card. Go ahead and on the top right corner, right above that chart, it says cart flag width. That's 0.02 meters. The width of this flag is 0.02 meters. Okay? All right, so what we're going to do is we are going to increase the distance between each gate with each trial run. Right now, the distance between the photo gates, which is your next to last column, is 0.1 meter. 0.1, so 0.1 m. So put that in the first, right here, distance between gates. You want to put 0.1 meters right here, the distance between gates. And go ahead all the way down and increase that by 0.1. So you'll have 0.1, 0.2 meter, 0.3, 0.4, 0.5, all the way till you get to the bottom. And go ahead and add another line under there, do a 0.8. I know it only goes to 0.7, but let's do a 0.8. We should have room to do a 0.8, so let's do that too. Okay. Devin, if you'll come up to do the computer once you get done. I don't think you have to record the height anywhere, but it's 13 centimeters high. The instructions said not to go over 15. So, all right. So trial 1. So this will be the first line on that chart. All right. It's recording. So your time in gate 1, 0.045. Your third column, time in gate 2, 0.033. And then you've got your time between gates, 0.182. I see that well on the video. Yes. All right, so now we're going to increase it to 0.2 meters. So I'm going to move it down. All right, we're just going to run it again. Here we go. This will be for the second line in the chart. So time in gate 1, 0.041. Get your time in gate 2 and your time between gates. All right. Let's move it down to do 0.3 meters. All right, ready? All right, here we go. all three times. All right, let's move it to 0.4. All right, you ready? All right, we're going to move to 0.5. There we go. Now, I'm not pushing it when I let it, I just let it go, and gravity's what's pulling it. I'm not adding any force to it. All right, 0.6. All right. There we go. Now, when it's talking about the time in the gate, that's talking about how much time it takes this flag to pass through. That's what it's measuring, is how much time does it take this flag to pass through that gate. All right, 0.6. 0.7, my bad, 0.7. All right. The last one, a 0.8. Let's try that again. It bounced back and got the flag. We may not be able to get anything accurate. Y'all see if you can catch the first number that shows up here, okay, before it bounces back. All right, let's try it again. 0.16, 0.016. I'm sorry, the first number here was 0.016. So under your distance for 0.8, did this change when that changed? I don't think so either. I think this. I think this is the only one that changed. So it's 0.016 right here. Time in gate 2. Okay. All right, so look at your data. What happened to the time in gate 1? Nobody wants to answer because we're on video, right? Did it change?
Yes.
Much? No, it didn't really change a whole lot. Why? I didn't move it. The position of gate 1 did not change, so I didn't move it. So no, you're not going to see much change in gate 1. What happened to the time in gate 2? It decreased. Every time it decreased. What about the time between gates? It increased. Is that what you would expect?
Yes.
Obviously, because you're moving the gates further apart, right? All right, so calculating the velocity in each gate. Let's go through the first line of what we're going to do. Okay? What's my formula for velocity? Distance over time. Okay? Same as speed. Velocity equals distance over time. What is, now let's just do, we're doing the first line. Let's do gate 1 of the first line. What is my distance?
Zero.
No.
Between the gates.
No, what's my distance at just gate 1? What's my distance?
0.01.
Oh,
0.02, because we're measuring the distance of, and somebody may have said that and I didn't hear it, but we're measuring the distance of the index card. Because that's where the time came from start to finish of this card that went through. So we're measuring the distance of the index card and the time it took it to pass through. Okay, so our time is, let's see. Our distance is 0.02 and our time is going to be 0.045. Somebody tell me what you got. I don't have that. Can't do that in my head.
0.4.
0.4 repeating. Alright, so we're just gonna go with, and what should my unit be?
Meters per second.
Meters per second. So every time I have a number, I need a unit. Alright. I'm gonna leave that up there, I just wanna make it a little smaller. Alright, we're gonna stick gate 1 over there. Alright, we'll go to another color for gate 2. Keep it separate. Alright, gate 2, what was my time? 0.033. What was my distance? 0.02, the width of the little flag on the card. 0.02. Now let me know what you get. 0.606060 repeating. Okay, so we're gonna go 0. Meters per second. Any questions so far on what we're doing? No. Alright, so that's gate number 2. That's the velocity. to gate number, I'm sorry, not gate number 3, the velocity between gates. Alright, so velocity between gates, where are we getting our distance and our time from?
The distance between gates divided by time between gates.
That's it, distance between gates divided by time between gates. So what is my distance between gates for our first trial?
1 meter.
0.1, and what is my time between gates? 0.182. So what do you get as your answer? 0.5494. Yeah. We're gonna say 0.55, and what's my unit? Meters per second. What is the difference between these two velocities and this one right here?
Those are going to the end of flag, one's going between gates.
Okay, so these are just measuring the flag at these points. This is measuring time between gates.
So one's average and one's instantaneous.
Which one's average?
Average is between, and then the ones at each gate is instantaneous.
So these are this is your average velocity of the whole thing. This is your instantaneous velocity at 2 different times, at these instants of these two. Okay? Question? Does that make sense? Alright, so what I want you to do, I want you to finish the chart. As you're finishing the chart, I'm going to input the data to make a graph. And if you finish the chart before we get ready to do the graph, then you can go ahead and start on the questions on the back. Okay? We good? Alright, so I put the data into the Logger Pro graphing software that's in the ASIM computer. We got time on the x-axis, velocity on the y-axis. Notice in number 3 it said to use the velocity at gate 2. So this should be your gate 2 velocities. Can y'all see that okay or no? I know it's kind of small. I'm going to read them out real quick. Check them with what you have. 0.61, 0.74, 0.83, 0.95, 1, 1.11, 1.18, and 1.25. Okay, so that was our gate 2 velocities, what we calculated. And the time was the time between your gates. So the time between these two. And we want to do the 4-step method to analyze the graph. So real quick, let's, I've expanded the graph, I've auto-scaled the graph, so let's get a straight line here. Oh, I can't use this one. So we got it to give us a linear fit. And y'all write this down. The slope, your M is equal to 0.8247. And it's given us our B of 0.4678. Y'all just write those to the side. We're not using them yet, but we're going to use those.
What did you say slope was?
0.8247 is slope, our M, and our B is 0.4678. So it plotted all our points for us, gave us a linear fit so we could have a straight line. So now let me swap over to my workspace. 6. 8247 and 4678. So we're just gonna have those off to the side. It says do a 4-step method to analyze the graph. So when we started the 4-step method, we always start with the equation for a straight line. What's the equation for a straight line? Alright, so we have y equals mx plus b. So let's start, the next step we need to do, we need to fill in our variables. What was on our y-axis in that graph I just had up here? What was on our y-axis?
Velocity?
Meters per second. Velocity. Which velocity?
Between the gates.
Between the gates.
That's the time between the gates. Which velocity?
Gate 2.
Gate 2. So that would be my... What kind of velocity would that be?
Instantaneous.
It's an instantaneous velocity. Which one? Thought I heard it. The second one, which would be our last. So what's the term we've been using? Final. Our final velocity. There you go. So that's going to be our final velocity. We're not going to worry about M and B yet. What was our X? Time. Time. Our X was time. Alright, that's the second step. So first step, we write the equation in the 4-step method. The second step, we're filling in what our variables are, final velocity and time. Alright, next step, let's plug in the numbers that we have that the graph gave us, our M and our B. So I'm going to change this. We're going to plug in our numbers. We're going to keep our variables. What was our M? 0.8247. So I'm just going to round that to 2 decimal places. 0.82. And we'll put in our time. Just going to put a letter T. What was our B?
2467.
Okay, so 0.47. Does that number look familiar? Look at your data.
Calculation velocity at gate 1.
Okay, there's a number like that calculated velocity gate 1. What else is it close to? Did y'all get the same thing? All the way down for gate 1? Yes. Calculated velocity for one of them was 0.47, right? Okay. Were they all close to that? Okay, your calculated velocities at gate 1, okay. So what would that be? What would this B represent? If it's 0.47, what does that represent? Which velocity? The gate 1, the beginning, the initial velocity. Alright, so what do you think the slope represents then? Acceleration. You got a velocity time graph. This 0.82, that 0.82 right here, that is your acceleration. This is your initial velocity. So now you've used your data to derive the formula you need to find acceleration. So you have VF equals A times T plus VI. So you've made a formula from the graph you have. Too much for a Monday morning, huh?
I don't know who put us in physics at 8 o'clock in the morning.
All right, any questions? No?